In this lecture we will study about the S parameter, and we will also try to find the reason why we do not use Y and Z parameter at high frequency. What is the effect of high frequency we will see, as well as in the case of high frequency we can't measure the instantaneous value, and open circuit and short circuit can be created only at one frequency or two frequencies, but it cannot be created for the broad frequency range. At last moment we will see the concept of S parameter also. So let's begin. This is a linear network because here I have used the resistance only, and resistance is the example of linear element. So combination of linear element will produce linear network. It's a two-port network. This is one terminal, this is one terminal. Combination of terminal is known as port. This is one port, this is another port. In one port, port number 1, there is voltage V1 and current I1. In port number 2, there is voltage V2 and current I2. If we want to calculate the Z parameter, how do we write the equation? You have studied already in circuit theory. V1 is equal to Z11 I1 plus Z12 I2, and second equation will be V2 equals to Z12 I1 plus Z22 I2. If I want to calculate the value of Z11 parameter, so in this equation I will put I2 equals to 0. If I2 is 0, then I can write Z11 equals to V1 over I1. What do you mean by I2 equals to 0 or I equals to 0? If I2 is 0, means this port is open circuited. This port is open circuited. Suppose that I want to calculate Z12, then what I have to do? I will put I1 equals to 0. Then if I put I1 equals to 0, then this equation Z12 will become V1 over I2, V1 over I2. If I1 equals to 0, it means that port number 1 is open circuited. Here I have solved how do we calculate Z11. Please see it. But in this case you can notice one more thing. If I want to calculate these Z parameters, then I have to create open circuit. What do you mean by open circuit? Open circuit means the value of current will be 0. If I solve this question, if I am calculating the value of Z11, then I will create open circuit. Open circuit means I2 equals to 0 at port number 2. There is no significance of this 8 ohm resistor when it is open circuit. So this network can be modified in this form, and here I can apply KVL, and with the help of KVL I can calculate the value of Z11, and Z11 is nothing but ratio of V1 over I1, but condition applied, I2 must be 0. Means overall we can observe, if I want to calculate the value of Z parameter, then I have to create open circuit. Similarly for Y parameter, same network I have considered. This is again, we can say it's an example of linear network because it is the combination of linear element. Resistance is a linear element. This is your port number 1, this is your port number 2. At port number 1, V1 and I1 are there. At port number 2, V2 and I2 are there. How do we write the equation for the Y parameter? I1 equals to Y11 V1 plus Y12 V2. Suppose that I want to I want to calculate the value of y11, then I will put V2 equals to 0. What do you mean by V2 equals to 0? V2 equals to 0 means V equals to 0 means it is short circuited. Suppose that I want to calculate the value of y11, then create short circuit means add these two terminal. We have added these two terminal, then we are trying to find the value of y11 here. If you create short circuit, then 4 and 2 ohm resistors will be parallel to each other. If we solve it then and apply KVL, then you will calculate y11. In this case, you can notice you have to create short circuit at the port, but remember that y parameter and z parameter, for the calculation of the y parameter and z parameter, you have to create open circuit and short circuit. Please remember that. And this open circuit and short circuit can be created only for low frequencies. And also remember that y parameter and z parameter are generally used at low frequency. Next thing is, what is the effect of high frequency? The well-known relation is C is equal to frequency into lambda. We can write lambda is equal to C over frequency. When I increase the frequency, lambda will reduce. As well as this, we have noticed that if we increase the frequency, then wavelength will reduce. Second thing is, what is the effect of high frequency? We say if we increase the frequency, operating frequency, then bandwidth will also increase. Let's take two examples. This is your copper cable. We know that the copper cable offers lesser bandwidth, while optical fiber cable offers larger bandwidth. The operating frequency of the suppose that for the copper cable is 3 kilohertz, and operating frequency for the optical fiber is suppose that 3 terahertz. In both cases, you can see the operating frequency for the optical fiber cable is high, so its bandwidth will be very high. Notice the effect of high frequency. If you use high frequency, then wavelength will reduce. If you use the high frequency, then your bandwidth will increase. Second thing, what is the effect of one point I told to you, at high frequency it is very difficult to measure the instantaneous value. So let's recall the basic definition of the frequency. Frequency is nothing but it's a number of cycles per second. This is 1 second. How many cycles are there? Only one cycle. So frequency will be 1 hertz. In this case, how many cycles are there in 1 second? 2 cycles are there. Frequency is 2 hertz. Now in this case, 1, 2, 3, 4. The frequency is 4 hertz. When you increase the frequency, the graph will become denser and denser. Okay, at this point we can measure the value, instantaneous value. At this point we can measure the instantaneous value. At this point we can measure the instantaneous value. At this point we can measure the instantaneous value. But when graph becomes denser and denser, you will not able to calculate the instantaneous value in the case of high frequency. In the case of high frequency, graph will become denser. You can't calculate the instantaneous value. Okay. Now let's see the effect at lower frequency. As I told, at lower frequency you can create open circuit or short circuit. For one frequency, for two frequency, you can create short circuit and open circuit. Now you are using high frequency, means bandwidth will increase. Suppose that This is the bandwidth. In the case of bandwidth, we always consider the positive frequencies. Remember it. What is bandwidth? Bandwidth means it's a range of frequencies. In this range of frequency, there are multiple frequencies, thousands of frequency. For the thousands of frequencies, you will not able to create the open circuit and short circuit, or it is very difficult to create the short circuit and open circuit in broad frequency range. Please remember. So that's why we do not use uh, Z parameter and Y parameter at high frequency, and generally we use S parameter in the case of high frequency. So what are the points that you have to remember? In the case of high frequency, we do not use Y parameter and Z parameter, because in the case of high frequency, the bandwidth will be more. Bandwidth is nothing but it's a range of frequency. Range of frequency means there are multiple frequencies, thousands of frequencies. For these frequency, you will not able to create open circuit and short circuit. Why I am saying open circuit and short circuit? If you want to calculate Y and Z parameter, means you have to create open circuit and short circuit. But remember that these Y and Z parameters are generally used at lower frequency, not in higher frequencies. In the case of higher frequency, again I am saying there is a range of frequency, bandwidth will increase. For the range of frequency, you will not able to create the open circuit and short circuit. So that's why we use S parameter at high frequency. So let's begin the concept of S parameter. So as I told, in the case of high frequency, we use S parameter, and the well-known relationship is C is equal to frequency into lambda. We can write lambda is equal to C over frequency. If you increase the frequency, then lambda operating wavelength will reduce. I have already discussed about the regimes, 3 regimes, and you can watch these 3 regimes in my transmission line playlist. There is a one thing, L is nothing but the size of element, lambda is nothing but it's a operating wavelength. If size of element is less than operating wavelength, size of element is less than operating wavelength, then we use circuit theory. Best example is, what is the size of resistance? It is about 3 centimeter. Resistance size is about 3 centimeter. Okay, it's a 3 centimeter. In for the circuit theory, what is the value of frequency? We use 50 hertz. And if you calculate the wavelength, then wavelength will around 6000 kilometer. Means you can say wavelength is very very high as compared to the size of the element. Then we use circuit theory. But when length, size of element is comparable to the wavelength, then we use wave theory, and size of element is greater than the wavelength, operating wavelength, then we use ray theory. Please watch it. Please watch it my lecture where I have explained about the regimes. Okay, let's see here. In the case of high frequency, we consider the wave behavior of the parameters. Okay, parameters means voltage or current wave. Suppose that it's a one port network. This is one terminal, this is one terminal. Combination of terminal is nothing but it's a port. It's a single port device. This is one conductor, this is one conductor. Recall the concept of transmission line. Transmission line is nothing but it's a 2 conductor system, and this transmission line is excited by source and terminated by some load, and any transmission line is characterized by the characteristic impedance. So A wave which travels from source to load is known as incident wave. A wave which travels from load to source is known as backward wave. But remember here, in this case we have considered the wave behavior. If we are considering the wave behavior, then which regime we will use? The second. Means in this case the size of element is comparable to the wavelength. So this one is known as incident wave and this one is known as backward wave. Similarly here, this conductor, this is one conductor, means you can say it's a this section is nothing but it is behaving like a transmission line. This is one conductor, this is one conductor. Compare with this one, compare this structure with transmission line. This is one conductor, this is another conductor. This line has some characteristic impedance Z0, as well as this port is offering some impedance. Okay, a wave which travel from source to load, a wave which travel from source to port is known as incident wave, that is A1. But you are getting some reflected wave at this point. At this point you are getting some reflection. What is the root cause of reflection? The root cause of reflection is the impedance of the transmission line does not match with the impedance of the load. In this case you can notice the Z0 is the characteristic impedance of this transmission line and ZL is the port impedance. Both are equal, yes or no? Answer is no. So you will get some reflection, and this reflected wave is represented by B1. And how do we calculate the reflection coefficient at this point? At this point we can write gamma L is equal to ZL minus Z0 over ZL plus Z0, and you can notice in this equation, if impedances are equal, then you will get no reflection. If impedance doesn't match, then you will get reflection. So in the case of high frequency, you have noticed that we always consider the wave behavior. This section is acting as a transmission line. It has some characteristic impedance. We are considering the incident wave. The incident wave always travel from source to load, and because of impedance mismatching we get reflected wave. Okay, so this is the one port network. Now I am giving the example of one port network. You have seen antenna, and in the antenna this is your source, this is your transmission line, and your antenna is acting as a load. A wave travels from source to load is known as incident wave, and wave which travels from load to source is known as backward wave. What is the root cause of backward wave? Because the characteristic impedance Z0 and ZL does not match. What is ZL? ZL is nothing but it's a dipole antenna. This ZL is nothing but it's a input impedance of the dipole antenna. Can we say this antenna is nothing but it's a single port device? Yes, you can compare with this one. In place of port you put dipole antenna. In place of this section you put transmission line. In place of source you put source. So remember that what are the things you have to remember. The first thing is, you at the high frequency you have to consider the wave behavior. Second thing, the combination of terminal is known as port. Third thing you have to remember, the wave which travel from source to load is known as incident wave, and wave which travel from load to source is known as backward wave. And what is the root cause of backward wave? Because the characteristic impedance of line and ZL does not match. So in this lecture we have discussed about only single port. In next lecture we will see the two port network and incident wave and reflected wave in that case also. So and finally I am going to conclude this topic. The Y parameter and Z parameter are not used in high frequency. What is the reason? Because for the calculation of Y parameter and Z parameter, you have to create open and short circuit. At high frequency, the bandwidth will be very high. Bandwidth means range of frequency. Range of frequency means multiple frequencies. For the multiple frequency, you will not create open circuit and short circuit. As well as we have noticed that the instantaneous value can't be measured at high frequency because you get dense type of graph. Okay, so this is all about why do we not use Y and Z parameter at high frequency, and what is the effect of frequency we have seen. Okay, thank you very much.